Hello, this is John Fitzmaurice, and this is my mathematical simulation of a full load rejection on a frame 5. So I have three graphs here. As it says, gas is the first one, torque is this one, the second, the green one, and speed is the red one. So the first 20 seconds or so is just to start the simulation. I didn't program in a starting means, a firing, and all that stuff. So it's really only a valid simulation at full speed or near full speed. So full load rejection on a frame 5 is, let's call it near full speed, because the governor should catch the rotor speed before the overspeed bolt at a lower speed than overspeed. So below 1.12 speed, 112% speed. So we come up, here we are, we have a 1 on gas. And remember, 1 is full. So 1 is full gas, 1 is full torque, and 1 is full speed. They're all done in 1 here in Bill Rowland's simulation. And then at 40 seconds, I programmed in a load rejection. So when you're at full load, your torque is balanced. So the torque here isn't the value of torque, it's the summation of the torque. And because speed isn't increasing, see speed here, there's no increasing, that means there was no excess torque. I was making enough torque to meet full load, but my gas was full open. So at 40 seconds, bang, I go to 1 torque, because fuel-wise, I was making enough torque for full load, wasn't I? And then I opened the breaker, so to speak, and I had excessive torque. So the governor catches it and lowers the fuel. Now this is, I have something here that's not completely correct, and that is, at this point here, on a normal unit, it would have caught at min fuel, before flame out, and I go to 0. So that's a little discrepancy I have to repair. But if I line them up, I went below 0 at just about my peak. So even if I correct that, my peak speed here might be 110, right? 110%. But it's very close. So this is from my recollection of working on turbines. This is about what happens on a full load rejection on a frame 5. You have a curve about like this, and so from 40 to, let's say, 55, which is 15 seconds to recover. The highest speed is 110%. The torque, when you open the breaker, it's going to be instantaneous. It's going to pop up, which is why the speed starts to come up. But as you cut back on fuel, the torque's going to go down. There's an overshoot on torque and on fuel, right? Which, like I said, I should have, if my model was better, I would take that out. And the speed comes back down. So it's very, it's a decent simulation. You could make some improvements, but not too bad. Okay, I'm going to do some other simulations, and hopefully I can learn how to present these better. Okay, thank you and bye.